Welcome to Science Made Easy by Teacher G. In today's episode, we're going to discuss covalent bond formation. So I hope everyone will enjoy and learn from this lesson. In the previous episode on ionic bond formation, we have introduced the two types of chemical bonding. These are ionic bonding and covalent bonding. In addition, we have also pointed out how ions form ionic bond. In this episode, we will discover how covalent bonding takes place. So what is covalent bonding? Covalent bonding is a type of chemical bonding which is being formed when two or more atoms share their valence electrons. The covalent bonding usually happens between two or more nonmetals. In this example, both oxygen and hydrogen are nonmetals. How does covalent bonding form? Let us take example of hydrogen and oxygen. In this example, we're going to solve for electron configuration, valence electron, Lewis electron dot structure, covalency number, and the central atom. The electron configuration of hydrogen is 1s1, while the electron configuration of oxygen is 1s2, 2s2, and 2p4. The valence electron of hydrogen is 1. This is because there's only one electron located at the outermost shell. While for the oxygen, the valence electron is said to be 6. This is because there are 6 electrons located at the outermost shell if we're going to consider their electron configuration. After we have solved the valence electron of hydrogen and oxygen, we're going to write down the Lewis electron dot structure of both atoms. Remember, in writing down the Lewis electron dot structure, we have to consider number 1, the chemical symbol which represent the nucleus and inner electrons, and the dot which represent the valence electron. So since hydrogen has one valence electron, we're going to add one dot beside the chemical symbol of hydrogen. Now, since oxygen has 6 valence electrons, we're going to add 6 dots around the oxygen. According to the octet rule, an atom will only become stable if it has 8 electrons at the outermost shell or its valence electron is said to be 8, except for some atoms such as hydrogen and helium. For hydrogen and helium to become stable, they need only 2 electrons at the outermost shell. By looking at the lead structure of both hydrogen and oxygen, we can say that both atoms are not stable. This is because the hydrogen has one valence electron, it needs another one electron to become stable. And oxygen, since it has 6 valence electron, it needs 2 valence electron to become stable. Since hydrogen has only one electron, it cannot give its one electron to oxygen. Otherwise, there will be no electron will be left for hydrogen. Now, oxygen might give its one electron to hydrogen, making the number of electrons of hydrogen 2, which will become stable. However, the valence electron of oxygen will be reduced to 5. Still, it is unstable. Since hydrogen and oxygen cannot give up or accept electron, they will share their valence electrons. To understand how hydrogen and oxygen share their electrons, let us solve first the covalency number. Covalency number pertains to the number of single electron in the lead structure or the electron that has no partner in the lead structure of both hydrogen and oxygen. The covalency number of hydrogen is 1. This is because there is one single electron in the lead structure of hydrogen, while the covalency number of oxygen is 2. This is because there are two single electrons in the lead structure of oxygen. After solving the covalency number of both hydrogen and oxygen, we're going to determine the central atom. In determining the central atom, we're going to consider the atom which has the highest covalency number. And in this case, the atom that has the highest covalency number is oxygen, meaning the oxygen will be the center of the molecule. So let us now analyze how hydrogen and oxygen form covalent bonding. Hydrogen has one valence electron and it will be shared to oxygen. Now the oxygen will share its one valence electron to hydrogen. The total now of valence electron of hydrogen will be 2 and that would be stable. Now since the hydrogen has shared one electron to oxygen, the total number of valence electron in oxygen is 7 and that is not stable. For the oxygen to become stable, one of its valence electron will be shared to the second hydrogen atom, and the second hydrogen atom will share its valence electron to the oxygen. The total number of valence electron in oxygen would be 8, which is said to be stable. And for the second hydrogen, there are two valence electrons, and the second hydrogen would also be stable. After sharing of electrons, there are two valence electrons now in the first hydrogen. There are 8 valence electrons in the oxygen atom, and there are 2 valence electrons in the second hydrogen. Following the octet rule, these three atoms are stable. Considering the valence shell electron repulsion theory, this would be the structure or geometry of H2O. So let us have another example. This time, let us identify how hydrogen and carbon form covalent bonding. So let us first solve the electron configuration, the valence electron, the leads, covalency number, and the central atom. The electron configuration of hydrogen is 1s1, while the electron configuration of carbon is 1s2, 2s2, 2p2. The valence electron of hydrogen is 1, since it has one electron at the outermost shell, while the carbon, the valence electron is 4, since it has 4 electrons at the outermost shell. For the lead structure of hydrogen, we're going to add one dot beside the chemical symbol H. For the lead structure of carbon, we're going to add 4 dots around the chemical symbol of C. The covalency number of hydrogen is 1 since there is one single electron in the lead structure of hydrogen, and the covalency number of carbon is 4 since there are 4 single valence electrons in the lead structure of carbon. Since carbon has highest number of covalency, the carbon will become the central atom. To understand how hydrogen and carbon form covalent bonding, let us analyze this. Hydrogen has one valence electron and it will be shared to carbon. The carbon will share its valence electron to hydrogen, making the total number of valence electron in hydrogen would be 2, which is stable. And for the carbon, the total now of valence electron would be 5. However, it is not stable. Thus, the carbon will react to 3 another hydrogen atoms. The second hydrogen atom will share its valence electron to carbon, making the total number of valence electron of carbon 6. The third hydrogen atom will share its valence electron, making the total number of valence electron of carbon 7. Finally, the fourth hydrogen atom will share its valence electron to carbon, making the total number of valence electron of carbon 8, and that would be stable. Following the octet rule, the 5 atoms are said to be stable. The 4 hydrogen atoms are stable because they have 2 valence electrons, while the carbon has 8 valence electrons. I hope you learned a lot from today's episode. See you next time. This is Teacher G on Science Made Easy.